A-level topic. It's integration of trigonometry. So this is specifically for A2. Okay, so find the integral of sec x plus tan x whole thing squared into dx. So what we're going to do first is we're going to expand the brackets and then write out. So sec squared x plus the expansion of the double bracket is going to be sec squared x plus 2 sec x tan x plus tan squared x, okay, into dx. So this is what we have. Now I've taken this out of your, if you're doing it Excel, this is from Excel, from the formula booklet. What we have here is the integral of 3 parts here. So what I normally do is I separate them. So you're doing integral of sec squared x into dx plus a constant should be taken out of the integral because we don't want to deal with things that are making it complicated. It's easier for us to take a constant out and then worry about the rest of it. And then the integral of tan squared x into dx. Okay, so this is what we have. So the integral of sec squared x, so what I've taken here is these are the functions and these are the differential, but we do know that the inverse is the integral of these functions, isn't it? So if we have sec squared x, the integral of that is tan x. Okay, so that's tan x. And then here we've taken the 2 out. So sec x tan x, the integral of sec x tan x is just sec x. So the 2 is in the front, so 2 sec x. Now tan squared x, it's not obvious and easy for us to integrate tan squared x just by itself. There is no clear link between its function and the integral function. So what we can do is what links tan to sec, for example. Okay, if you remember from your formula, is sec squared x from trig identities that you learned previously, is sec squared x is 1 plus tan squared x. It's 1 plus tan squared x. Okay, if you don't know where it comes from, I'll do like a series of videos on trig identities and what you need to remember, and then you can have a look from there. Okay, if you rearrange it for tan x, you're going to get sec squared x minus 1 here. Okay, so we're just going to plug that in here. So rather than having it as a tan squared x, we're going to write it as sec squared x minus 1 into dx. Now you can easily integrate that. We know that sec squared x is tan x here, and the integral minus 1 is just x. Okay, so let's rewrite that. So tan x plus 2 sec x plus the integral of sec squared x is again tan x, and then minus x plus c. Don't forget the c. The final answer, if you want to collect the like terms, you're going to end up with 2 tan x plus 2 sec x minus x plus c. That's your final answer. Thank you for watching.